Hey everyone, today we are going to be talking about reflections of points in the coordinate plane. So yesterday we talked about the coordinate plane and how to plot points and how to identify points. Now we are going to start using those points on the coordinate plane to do other things, the first one being reflections. Our vocabulary here says a reflection is the mirror image produced by flipping a figure across a line. So a lot of times the line is going to be the x or the y axis, but it can be other lines on the graph. In the coordinate plane, when you reflect a point, you name the reflected point by using prime notation. So it says in the figure, the point -4, 0, so that's this point over here, is reflected to a prime 4, 0 across the y-axis. And this a prime with a little like apostrophe on it, that's your prime notation. So we have an original point, and then we want to label our new point in a little bit different way. So in our first example here, it says write the ordered pair that is a reflection of -3.5, 2 across the x-axis. What I want you to do is I want you guys to highlight the axis that you are going to flip over. So I'm going to highlight the x-axis. Then to reflect the point, I'm going to count the distance I am from that axis. So I am 2 spaces away from the x-axis. That means I need to go 2 spaces away on the other side. So this is going to be a prime. And then I'm going to label that ordered pair. So this is going to be -3.5, -2. So it says give the coordinates of the reflected point, -3.5, -2. So now we're going to practice it a couple more times. Use the coordinate plane to complete the following. Use the coordinate plane to reflect 1.5, 2.25 across the x-axis. So I'm going to highlight the x-axis here. And I am going to say that that every other box is going to be 1, just to kind of make it easier for myself. Oops, too far. So -1, -2, -3, 1, 2, 3, makes it a little bigger, -1, -2, oh, I went too far. So this is -1, -2, -3. So I'm going to plot the point 1.5, 2.25. So 1.5 is going to be in between 1 and 2. And then 2.25 is actually going to be in between here. So it's going to be in between the 2 and then the half. So this is going to be point Q. And I want to reflect it over the x-axis. So I'm going to count the spaces that I am away. So I'm actually 2.25 spaces away. So this is 2.25. So I want to go 2.25 to the other side. So 1, 2, and then 0.25. So this is going to be Q prime. And I am at 1.5, -2 and 1/4. So to give the coordinates of that reflected point, I'm at 1.5, -2 and 1/4. If I do it with 3, 2, so here's 3, and then I'm going to go up 2. So here's my 3, 2. That's going to be point B. I am 2 units away, so this is 2 units. So I'm going to go 2 units to the other side, so 1, 2. So my B prime is at 3, -2. In example 2, I'm going to reflect across the y-axis. So this time when I highlight the axis that I'm reflecting over, it's going to be the up and down axis. So this says Delaney is building a square fence. She places fence posts at the locations indicated on the grid. So here are my 4 fence posts, 1, 2, 3, 4. What is the location of the post that reflects S -2, 2 across the y-axis? So this time I want to count the spaces in between these 2 things. So I'm 2 spaces away. So I'm going 2 spaces away to this side. So this is going to be S prime. S prime is going to be at +2, +2. So I can see that the x coordinate changed from -2 to +2. So on this one, again, I'm going to go with every other one is 1. So 1, 2, 3, and I'll just make an extra tick mark for 4. So -1, -2, -3, and then again an extra tick mark for -4. and then 1, 2, 3, and then an extra tick mark up here for 4, and then an extra tick mark down here for 4. So -4, -3, -2, -1. So for -4, comma 4, I'm going to go out to -4 and then up to +4 up here. So this is going to be point Q. And I want to go across the y-axis this time, so I'm going to go across this one. So I'm 4 units away. So I'm going to go 4 units to the other side. So I'm going to be up here. And this is my Q prime. So +4, comma +4. For 2.5, comma -3.5. So I'm going to be over at 2.5, down all the way to the bottom here. So this is going to be B. And then I want to go to the left now. So I am actually 2.5 units away, sorry. So I want to go 2.5 units to the other side. So -2.5 is going to be over here. So I am at -2.5, comma -3.5. So now that we've done this where you're given the point and you're actually reflecting that point over to the other side, now we are going to go to what if you're not given a graph and I want to know what reflection you did. So did you go over the x-axis or the y-axis? So we're going to kind of put all these things together. So if I'm identifying the axis of reflection, it says when a point is reflected across the x-axis, so I'm going to go back up here for a second. When I reflected across the x-axis, I can see that the x-coordinate stayed the same and that the y-coordinate is the opposite sign. So this says when a point is reflected across the x-axis, the x-coordinate is going to stay the same and the y-coordinates are opposites. When a point is reflected across the y-axis, the y-coordinate stays the same and the x-coordinates are opposites. So when you're looking at the 2 points that you're given and you want to decide which axis did you flip over, so which one did you reflect over, you want to find the coordinate that stayed the same because that's going to tell you which axis you flipped over. So when I look at point A and point A prime, -2 3/4 and 2 3/4 and -2 3/4 are different. But the -4 is the same. So my y coordinate stayed the same. That means I flipped over the y-axis. In part B, the y-coordinate is also the one that stays the same. So from point M to point M prime, the -1 stayed the same. So we are flipping over the y-axis. In part C, the 10.2 is the one that stayed the same. So my axis of reflection is the x-axis. And here it says to highlight the coordinate that stays the same because the one that stays the same tells you which axis you reflected over. So if you reflect over the x-axis, the x-coordinate stays the same. If you reflect over the y-axis, the y-coordinate stays the same.